In this lesson, I'm going to show you where the quadratic formula actually comes from. So remember what the quadratic formula says. Quadratic formula says if we have something in standard form, then the x-intercepts, or the x values that satisfy that equation, would be the opposite of b, plus or minus the square root of b squared minus 4ac, all divided by 2a. So let's see if we can figure out where that comes from. Before we talked about the quadratic formula, we talked about something called completing the square. When we did this problem earlier, we might have had x squared plus 4x minus 5, and we had to do all 4 different steps. Well, what if the front number was a 2, and what if this was a 6? We would still do the same 4 steps. And eventually we're always doing the same 4 steps, and we're just getting a different answer. So in math, sometimes what we do is we generalize. We say that instead of those numbers being specific constants, let's try to complete the square with variables, a, b, and c. So a, b, and c could be any number that we want. Let's go through our steps to complete the square. Now the first step to complete the square was that we isolate the x's. So that c doesn't have an x, so it's going to get out of the way. The next step was we factor out the leading coefficient, which is a. I'm going to divide each of these terms by a. And then what I'm going to do for my third step is take half of this middle term and then square it. So half, instead of dividing by 2, we can multiply by 1/2. That would be b over 2a. And then b over 2a squared would be b squared over 2a times 2a is 4a squared. That's our third step. For our fourth step, we take that new number, multiply it by a, and then subtract it. So I'm going to be subtracting b squared over 4a. By multiplying by a and dividing by 4a squared, it actually cancels with one of these. So you get 4a. Let's actually combine those two numbers, so we just have one fraction. So I'm going to combine these two. Let's get a common denominator of 4a. Multiply the c by 4a over 4a. And let's see what we get. We're still going to have a here. And this is going to be x plus b over 2a. Remember we said to go from completing a square, it's always going to be half of our middle number. So x plus b over 2a. Now we're going to have negative b squared plus 4ac all divided by 4a. That's going to be the fraction we get by combining those two. So let's bring that on the other side. So we're going to be subtracting negative b squared plus 4ac over 4a to both sides. So that'll cancel this out. It's going to get it on the right side. And when we subtract, that's the same thing as multiplying by negative 1 over 1. So this is what we wind up with. A times x plus b over 2a squared is equal to b squared minus 4ac all over 4a. Now it's starting to take shape. Let's get the x by itself by dividing both sides by a, or multiplying by 1 over a, and we get x plus b over 2a squared is equal to b squared minus 4ac over 4a squared. We could take the square root of both sides. This, remember, turns into absolute value. And this would be the square root of b squared minus 4ac all divided by square root of 4a squared is just 2a. We can get rid of the absolute value by writing plus or minus. And then just bring this fraction over to isolate the x. And you get x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a, or bringing it all together, x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, the common denominator. That's where the quadratic formula comes from. It comes from generalizing, completing the square from a standard form of a quadratic equation.